Okay, so we're going to apply the same principle to problems that do not have a standard deviation of 1 and a mean of 0. So in other words, we're going to move away from z-scores and find x scores or x values. We have this formula right here, and this formula is derived from this. Remember, this is the formula for the z value. You take the x value, subtract the mean, divided by the standard deviation. Not that you care, but I was going to show you that if you solve this for x, you get the x by itself. Then this is where this formula comes from. To get the x by itself, we undo everything that's happening. You will not have to do this. But if I multiply both sides by the standard deviation, okay, those two cancel out. And then that leaves me with z times the standard deviation is equal to x minus the mean. I'm trying to get x by itself, so I undo that subtraction. So I add the mean to both sides, add the mean. And so I get the mean plus the z-score times the standard deviation. Those two add to 0. And I now have the x by itself. So that's where that comes from. And these are just saying, okay, if this is the mean is 9. My pen is not working right. The mean is 9 and the standard deviation is 2. Find the weight x. So find the x value. So this is just a simple plug and chug. X is equal to the mean is 9 plus the z-score. They give us the z-score is 1.96 times the standard deviation of 2. And then that's just a calculator problem. 9 plus 1.96 times 2. And so that x value is 12.92. Do the same for those two. This one you should know, though. The z value is 0. If the z value is 0, then our x value is going to be 9. Why? Because 0 is the mean on the standard normal distribution curve. So whatever, if we're talking about a z value of 0, that is the mean. So the mean is 9. But if you plug it into this formula up here, it'll calculate out to be 9. So do the same thing for number 2. Plug it in. This is number 1. This is number 3. Let's see what else. Scores for the California Peace Officers Standards and Trainings Test are normally distributed with the mean of 50 and a standard deviation of 10. An agency will only hire applicants with the scores in the top 10%. That they're giving us the area. What is the lowest score an applicant can earn and still be eligible to hire for the agency? So they just want a score. That's an x value. They've given us everything that we need. So that is just the same thing, z times the standard deviation. We need a z value, though. The area is 0.10. And in order to find the x value that we need this z value. So they're giving us an area. Now, if you're using StatCrunch, you don't need the z-score. You don't even need this. If you're using StatCrunch, you can go and get the number straight away just by simply typing it in. So they want to know, okay, so the top 10%, you kind of have to understand that the area to the right, we're talking about this 10% is an area to the right because that's the top 10. That changes to an area of 0.10. Remember, that's the area to the right. If the area to the right of this either Z or X value, we're going to go ahead and make it an X value right now because I'm going to do it on StatCrunch first. So the average is 50, the standard deviation is 10, and they want it to be in the top 10%. Well, if the top 10% is this way, then we know that 90% is this way. Okay, we don't really need to know that for StatCrunch. I haven't clicked on StatCrunch in a while, so it might be asleep. Okay, so we want to go back to standard because we're not doing between. We do want greater than. We want our area to be 0.10%, but we're no longer using a mean of 0 and a standard deviation of 1. We're using a mean of, what was it, 50? And a standard deviation of 10. I'm going to check and make sure that was right because a mean of 50 and a standard deviation of 10. All right, so all we have to do now is compute. And that means that the score has to be 62.82. They didn't give me a rounding rule, but that's what the score has to be. That's the lowest score that you can make and be in the top 10%. So that's the answer to the question, but I want to show you how it will work if we calculate the z-score too. So this is an x value right here of 62. What was that? 62.8. 62.8. So to find it like this, we would need to find a z value. So a z value for 10%. So if you're going to use StatCrunch, you might as well just use StatCrunch this way. But I will go back and show you. If you type that in and make that 0, and you type that in and make that 1, we're going to delete that, and we're going to change that to 10%. Then we get a z-score right here of 1.28. So if you go over here now and take that z-score, and here we would be on not an x-axis, but a z-axis, and we would still be doing 10%. And our z value, it said, would be 1.28. And so if you come over here now and calculate, our mean was 50 plus our z-score, 1.28. Wasn't that what it was? 1.28. And multiply that by the standard deviation, which was 10. We can get 50 plus 1.28 times 10, and that will give me 62.8. And I believe that was exactly what StatCrunch gave me, 62.8. Now, we did, I'm forgetting, what did I just do? Oh, we used that. I couldn't remember what I did. So we used this right here to get that. So again, I would if I was going to use the z-score, I wouldn't use this just because it's so much easier just to go ahead and type in 50 and the 10 right here. But if you're using the calculator to find your z-score, you would still have to use not the 10%, which is over here. Oops. This right here is 10%. Then this over here is 90. This is 10%. This over here is 90%. And so this is the area to the left is this 0.9 right here. So that's what we would have to type in the calculator. So we would do distribution, inverse norm, type in 0.9. Now here you can calculate the z-score or calculate the x-score. Since we can type in the 50 and the 10, it will go ahead and calculate the 62 for you. You just have to put in the 90 in order to get this calculation. But notice it tells me 62.8. Or you could still do the area. You could still find the z-score, leave that 0, leave that 1, and then get the z-score 1.28, and then do the same calculation that we did right here, 50 plus 1.28 times 10, and that would still give you the 62. And then lastly, you could go to your calculator, to your Z table and look up the area of 0.9. Now it's not going to be exact, so you'd have to pick. There's 0.8997 and 0.9015. So this one I think is actually a little bit closer. It's only 3/10 or 1/10,000ths of away from being 0.9 exactly. So if you look at this one right here, then it's 1.28, which is what we were getting. 1.28, which is what we were getting right here. 1.28. You're going to get the same thing. So I'm going to let you, this one right here is the bottom 1%. I'm not going to do the whole thing with you, but I will help you get it set up. So what are they talking about? What should your picture look like in a random, the mean total? This is your mean, and your standard deviation is 38.9. Find the highest cholesterol level you can for women of this age group and still be in the bottom 1%. So they're talking about being in the bottom 1%, so they want less than 1%. So this area right here is the area to the left, and it's 0.01. So that should be pretty straightforward. You can use the Z table, you can use the calculator, or you can certainly use StatCrunch to find that. And don't forget, I do have the answers to these posted online.